Alright, rails. Introduction. Rails are a member of the track laid in two parallel lines to provide unchanging continuous level of the surface of the movement of the train to be able to withstand stress. They are made of high carbon steel. And standard rail section of their specification varies type of the rail that is discussed in Chapter 6. One function of the rail. The rails are similar to steel girders. They are provided to perform the following functions of the track. They reduce the continuous level of the surface of the movement of the train. They provide the pathway which the smooth with very little friction. Friction between the steel wheel and the steel rail is about one-fifth of the friction between the pneumatic tire and metalled road. Rail surface with lateral guide of the wheels, rail bearers, the stress developed due to the vertical load transmitted through the axle of the wheels of the rolling stock as well as due to the braking and thermal forces. Rail carry out the function of the transmitting load to the large area with the formation through the sleepers and bells. The types of rails. First, rail was used with a double head made of an I double bell section. The idea with the figure of 6-1 with the idea with that once the head wore out during the surface of the rail could be inverted with the reused experience however to show that the while on surface of the bottom table on the table of the rail was dented to the such extent that because of the long continuous contact with the chair that it was not possible to reuse the lead. This has led to the development of the bullhead rail, which has been almost a similar shape, but more metal in the head, but better than withstand the wear of the tear. The rail section had a major drawback for the care of that the chairs were required for the fixing of the sleeper. The flat-footed rail, also called the Vignol rail, figure 6-3, with an inverted type of the cross section, inverted T type, therefore developed, which could be fixed directly by the sleeper with the help of the spikes, and another advantage of the flat-footed rail was more economical design with the greater strength with the lateral stability of the track compared with the bull-headed rail. Given the cross-section, however, the flat-footed rail has been standardized as adoption in Indian railways. Double-headed rail shown in 6-1, the bull-headed rail shown in 6-2, and also your flat-footed rail showed the first fish angle, the foot in the web, and the head in the crawl, and the height. The requirements of the ideal rail section, section as well should have the most economical, consistent with the strength and stiffness and durability. Center of the gravity rail section should be preferably very closely the mid height of the rail with the maximum tensile strength of the compressive stress is equal. The rail primarily consists of the head of the web of the foot, and there should be an economical balance of distribution of metal of the various components of each of them and fulfill the requirements properly. The requirements as well as the main consideration for the design of these rail components is follow the head of the rail should be adequately depth low of the vertical where the rail should also be sufficiently wide so that not only the wider running of the surface available, but also the rail is desired lateral fitness. The web should be sufficiently thick of the withstand the stress of the rising due to the loss of the load of bones by it for allowing the normal conclusion. The foot should be the sufficient thickness to be able to withstand vertical or horizontal by allowing for loss due to the corrosion. The foot should be wide enough for stability against overturning. The design of the foot should be sure such that it can be economical and efficiently rolled. Fishing angle. The fishing angle must ensure the proper transmission of the load through the rail of the fish plate. The fishing angle should be such that the tightening of the plates do not produce the excessive stress on the worn of the rail. Height of the rail. The height of the rail should be adequate so that the rail is sufficient vertical stiffness and strength of its beam. 631 standard rail section. The rail designated with the weight per unit length with the FPS unit, the weight in the pounds per yard, and metric unit with the kilogram per meter. The 52 kilograms per meter denotes that it has a weight of 52 kilograms per meter. The weight of the rail. The section is decided after the consideration such as the following: heaviest axle load, maximum permissible speed, depth of the ballast cushion, type of the spacing of the sleepers, other miscellaneous factors. Standard rail section Indian railways are 60 kilograms, 52 kilograms, 90R, 75R, 60R, and 50R, but the total heavier rail sections of 60 kilograms to 52 kilograms were recently introduced, designated the metric units. Other rails designed or per the revised British standard specifications are designated the FPS unit through the dimension weight of the metric unit of the nomenclature N90R and S75R. R stands for the revised British specification. Every the railroad has been branded on its own web with repeated with the intervals of the per IRS T1288 the brand marks as follows. The IRS 52 kg 710 Tisco 2 1991 OB. Definition of very abbreviations as follows. IRS 52, number of the IRS rail section 52 kilograms 710, grade of the rail section Tisco, the name of the manufacturer Tat Iron Steel Company. 2, the month of the year and the year of the domain manufacturer. The arrow stands for showing the direction of the top of the ingot, and OB stands for processing steel open-hearted basic. A brand marks for the rail will be rolled in letter with at least 20 millimeters in size and 1.5 millimeter in height, and intervals of 1.5 to 3 meters. The standard rail section, standard rail length prescribed in the Indian railways are given in Table 6.1. Our broad gauge 60 kilograms a meter, 52 kilograms a meter, 90 pounds a yard, and 13 millimeters for 42 foot per old standard. Meter gauge 90 pounds, 75 pounds, 60 pounds a yard. Our RBS 12 millimeters, 39 feet as per old standards, except for the 90 pound rails, which are 13 millimeters length, and narrow gauge to 50 pounds a yard. RBS type of section, and 12 millimeters, 39 feet per old standards. UIC, International Union of Railways, IRS, International Railroad Standard, RBS Revised British Standard. Detailed dimensions, standard rail section figure 6.4 and 6.2. The neutral horizontal action, the neutral vertical axis, B and A, and also your tensile side and your compression side, E and F. Standard foot rail length. Detailed standard rail sections, weight in meters and kilograms of area section dimensions A, B, C, D, E, F. It's mentioned in here that the 90-hour rail section is adequately only for the annual transit traffic density with about 10 gross million tons per kilometer annual. Speed up to 100 kilometers per hour. Axle load the main line. The standard service life about 20 to 25 years. Revising these limitations, Indian Railways in their 1959 designed heavier rail section, 52 kilograms a meter, to meet the requirements of the heavier and faster traffic. This rail section commended the use of all the broad gauge mainline routes and was featured with up to 130 kilometers per hour with a traffic density of 20 to 25 gross million tons. Important 52 kilograms to 60 kilogram as shown in figure 6.5. 6.5 shows the 52 kilogram on the right and B as in the 60 kilogram on the right. Neutral axis, tension side, compression side, and normal axis. The traffic density of the broad gauge traffic routes and Indian routes increase with the various accordingly to meet the final requirements of the traffic. The new design has final weather 60 kilograms of the UIC sectional rail. The rail section has been designated with the speeds up to 160 kilometers per hour with a traffic density of 35 gross million tons. Alright, the weight of the rails. The weight of the rail of the section depends on the various consideration heavy the actual load of the rail to carry the plate for the important role of the following of the thumb rail defined with the maximum axle with the relation of rail section maximum axle load 560 times sectional weight of the rail in the pounds per yard over the kilograms per meter. For 90 yards per yard, maximum axle load is equal to 560 times 90 pounds or 50,400 pounds. And 52 kilograms per meter, the maximum allowable to fix 560 times 52 kilograms, 29.12 tons. Length of the rail. Theoretically, the longer the lesser the number of the joints and fittings required, for the lesser of the cost of construction and maintenance, the longer the rails economically provide smoother and comfortable ride. The length of the rails, however, is restricted due to the following factors. Lack of facility transporting long air rails, particularly on the curve. The difficulty of manufacturing very long rails. Difficulties requiring bigger and expansive joint with longer rails. Heavy internal thermal stress for the long rails. Taking the above factors into consideration, any rail standardization wrinkle of 20 meters, broad gauge 12 meter, previously 39 feet, meter gauge and narrow gauge Indian rails are also planned to use 26 meters, even longer rails in track sections. 6.4. Rail manufacturing. Steel U, but the manufactured rails made from an open heart with a duplex process that should not have the wide variation. The chemical composition with the essential for the four-stage manual rail manufacturing. Steel manufacturing process using the basic oxygen electrical arc furnace, including the argon rising, degassing, continuous casting of the blooms rail rolling process, including control cooling, rail finishing, including eddy current testing, ultrasonic testing of finishing work. The typical flow of the manufactured rail of the Blala steel plant in India is given in fixed specs. 641. Rail specification. The specification of a flat-bottom symmetrical rail, the quality of the steel of its manufacturing process, the chemical composition, acceptance tests, and the qualifying criteria, other technical conditions given below. The quality of the steel, the shape of the rail there should be made be fully killed quality and should conform with the chemical composition, mechanical properties specified in the table. 3. The branding of the stamping. Rail should be hot branded on one side of the web, showing the relevant detail of each of the rails should be identified with a hot stamping at least for every 4.0 millimeters, 4 meters on the web, and should be color coded in order to distinguish the grade and class of the length of the other special requirements. You have the blast furnace, hot metal with the converter shop, the liquid steel with the vacuum degassing, the clean liquid of the steel with the H2 standard bloom casting, blooms in the reheating furnace, the 950 millimeter rough strand, 800 millimeter intermediate strand, 850 millimeter finishing strands, hot saws, one line computerized stamping machine, cooling bed, slow cooling pits, biplanar planer, roller, straightening machine, online eddy current testing, online ultrasonic testing method, cold carbon saw mill machines, inspecting beds and refinishing group and dispatching section. Process for the rail manufacturing Behali Steel Plant, India. Desirable properties of the steel of the rails. Each section of the rail should adequately be rolled in respectively the paper before the manufacturer approved the purchase of the inspecting agency with the permissible tolerance and variations. Free of the defect, the rail should be free of all the detrimental defects such as the cracks of all kinds, flaws, the piping, and lack of the metal having unfavorable effect of the behavior of the rails in service. Straighten it. The rail should be absolutely straight with the tolerance of the end of the straight, the very stringent, as required in Table 6.2. You have your horizontal deviation of half a millimeter measured with the maximum order of the quarter with a 2 millimeter standard straight edge on the Class A rails. The Class B rails, the deviation of 7 millimeters measured with the maximum order of the quarter of 1.5 millimeters on the straight edge. Vertical upsweep deviation of the 4 millimeters of 4/10 of a millimeter maximum of the ordinate with the quarter of the 2 millimeter standard straight edge. The Class B rails, deviation of a half a millimeter measured by the ordinate with the quarter of the 1.5 millimeter standard straight edge. Down sweep is not listed. Permissible variation dimensions of the tolerance allowed with the various parameters of the rail section given in the table 562 for the 6.5. The tolerance are subject to the condition of the actual weight determine the weight of the rail piece of the falls in fifth of a percent below or 1.5 above the calculated weight. The permissible variation dimension rate overall height is a positive 8 millimeters to 2 or minus 4/10 of a millimeter. Weight of the head plus or minus 5 half a millimeter. Width of the head of the measured 14 millimeters below the rail of the top. Width of the flange 1 plus or minus 1 millimeter for sections less than 60 kilogram meters. 1.2 millimeters minus 1.1 millimeter for section 60 kilograms and above. Thickness of the web 1 millimeter to negative half a millimeter. Measure the point of minimum thickness of the vertical flange plus or minus 1.2 millimeters for the flange weld with less than equal to 150 millimeters. Base rail should be truly flat and slight concavity not exceeding 4/10 of a millimeter is permissible. Length of the rail is 2.2 millimeters to negative 10 millimeters. Alright, fishing surface. The standard template with the rail fishing surface should not stand with the wave of the contour of the wave of the be of 121.2 millimeters of the clearance of the finishing surface should not exceed 18 hundredths of a millimeter at any point. And square of the deviation from the square of the horizontal vertical direction should not exceed 6/10 of a millimeter. The straighten if the maximum permissible deviation is 7/10 of a millimeter. Measure the maximum ordinate chord of 1.5 millimeters. Wave of the kinky, the twisted rail should not be accepted. End of the straightness. Rails are classified in A or B category. The details are given in Table 6.4. Fish bowl, the diameters holes are plus or minus 7/10 of a millimeter. Centering in position with the holes vertically or plus or minus 7 millimeters horizontally. Important test rail. The following tests are conducted to determine the serviceability of the rail section. Falling weight upon the top or tup test. A rail piece at 1.5 millimeters covered the rail support between the rear bearings. The prescribed distance to the top of the specific weight of 1,000 kilograms for a 90R rail with a drop at the height of the 7.2 millimeters. Standard for the test of the rail. Test piece specimen should be withstand with the blow with any of the fracture only. We have fall weighting done with every calf at 100 metric T. The weight of the top of the descent between the center of the bearing, weight of the drop, different tail of the section is given in Table 6.6. Show of the rail section weight of the top of the distance between the center of the bearing and the height of the drop. The tensile strength of the test for the piece is taken with the head of the rail section subject to the tensile strength. Tensile strength of the rail should not be less than 72 kilograms meters squared for the millimeter squared for the minimum elongation. 14% medium maximum magnesium rail. 12% for the carbon quality rail. The testing optional to be carried out when required with the inspecting official. Hammer test. The foot of the rail piece with the edge grabbed with the vertical position. The head of the rail struck with the 4.5 kilogram hammer. The sufficient number of the blows are given to the weld bend for the dimensional value. With the A given in the table 6.7 and the figure 6.7 is achieved. No fracture should occur with the lap of the B closed or otherwise be batched with the rejected. The test is no longer required for the IRST 1888. The value for the A or various rail sections are listed in table 6.7. 6.7 shows the hammer test values. 6.7 values are different from the rail section. Rail section 52 kilograms 90R. RM, 75 RM, 60 RM, 50 RM. Dimensions A in millimeters are 157 millimeters, 144.5 millimeters, 130 millimeters, 117.7 millimeters, and 108 millimeters. The 642, the second quality rails that have rejected either individually by casting or have failed to fulfill the requirements of the IRS specification in the number 212 with regard to chemical composition have failed to do the defect surface dimension with the length may be accepted. The second quality T18 for the use of the loop of the siding. These second quality rails should conform with the following specifications. Chemical composition of the rails should conform with the values given in carbon, magnesium, sulfur, phosphorus, and silicone in a percent of the carbon steel, medium magnesium steel, and revised medium magnesium steel. Surface defect. The following minimum dimension of the rail surface is considered the minor defect of the rails where these defects are accepted. The table of the rail, top of the rail, table of the rail, 8/10 of a millimeter. Side of the head of the rail, 1.6 millimeters. Bottom side of the rail, 1.6 millimeters. Permissible variation of the dimension. Overall height of the 1.6 plus 1.6 millimeters. Negative 0.8 millimeters. Weight of the head of the 1.2 millimeters. Thickness of the web, 1.6 millimeters to negative 0.6 millimeters. Length of the rail, 25 negative plus or minus 25 millimeters. Difference of the theoretical actual weight. Such rails are identified as chamfering a 6 millimeter diameter hole at either end of the long side of the center of the rail, the middle of the well of the rails are also used only with loop line siding with speed restrictions and with the 50 kilometers per hour. These rails are painted orange on both sides of the web, the length of 1 meter from each for the identification. 643 third quality rails. The rails that do not conform with the standard of set forth in first and second quality are still fit for use for the railway track for safety consideration or use for the industrial sidings where speeds are restricted 30 kilometers an hour for broad gauge and 25 kilometers for meter gauge. Since the rails identify the chamfer the 12 millimeter diameter hole at the end along with the center of the rail, the middle of the web, the 18 millimeter marking IU is shaped stamped on both ends of the faces. The third quality rail is painted white on the end of the face of both sides of the flanging wheel, length of the 50 millimeter from each end of the identification. Third quality are manufactured use of rejected bent heat wheels which do not conform to the IRS T12 and 218 standard with regard to the chemical composition, serve the defects, dimension, and straightness. 644 90 UTSL rails. The Indian Railway has been using modern magnesium rail with the ultimate tensile strength with over 72 kilograms per millimeter square, manufactured by Valhalla Steel Plant, surfacing 52 kilograms. The 72 ultimate tensile strength of the rails is only at 350 gross million tons. Only the section with the annual traffic distance with the 20 gross million tons, but the renewal cycle is also about 70 to 18 years, which is rather as compared to the surface life of 50 years. But the concrete sleep of the mower of the surface review. Rails were faster on the curve of the gradient section. The view with above the consideration, any rails have been imported with the 25 kilograms of 90R with the 90 ultimate tensile strength. From some time, the rails have the following main advantage. The surface life of the 90 ultimate tensile strength rails is about 50% more than the conventional medium magnesium 72 ultimate tensile strength rails. The total gross million tons of 72 and 90 ultimate tensile steel rails can be carried during the primary surface life as follows. 52 kilograms at 72 UTS is 350 gross million tons. 52 kilograms, 90 UTS is 525 kilograms gross million tons. 60 kilogram, 90 UTS is 900 gross million tons. 90 UTS, 90 ultimate tensile strength rails are more stringently against the wear of having the hardness about the 270 brillion hardness number and against the 220 brillion hardness number of medium magnesium rails 72 ultimate tensile strength. The allowable share of the stress for the 90 ultimate tensile strength rails is much higher as can be with the comparative figures below. Medium magnesium rail of the 72 unit ultimate tensile strength of 18 kilograms per millimeter squared, where resistant rails of 90 ultimate tensile strength of 22.5 kilograms millimeters second squared. Students have shown the maximum strength of the box and wagons may be ordered to 20 kilograms millimeters squared. In which excess of the permissible stress the medium and maximum 70 ultimate tensile strength of rails. Therefore, the rails for the box and wagons are running, and it is desirable to have the 90 ultimate tensile strength rails. All right, end hardening of the rails. The rails where they end with the hardening by oil and water, quenching the the wear of the tear and the end of the batter of such rails is considerable less. The rail and the heads have been hardened by passing through them in the thermal treatment plant. But the head of this hardened to the depth about 12 millimeters from the surface of the head of the hardened rail have a longer surface life that extends 2 to 3 times more compared with the ordinary magnesium rail. The chemical composition of hardening steel rails at grade 1080 is described in table 6.9. The item limited value 0 carbon, magnesium, silicon, sulfur, and phosphorus. 6.5 rail wear. During the passage of the moving load with the friction between the rail and the wheel, the rail heads gets out of the worn of the course of the surface. The impact of the moving load is affected with the force and acceleration, deceleration, braking of the wheel, the aberration due to the rail with the wheel interaction, the effect of the weather conditions, such as the change of the temperature, snow, rail, rain, the presence of the material as stand, but the stand maintenance of the straggle is such as the allied force of the considerably wear and the tear, the vertical lateral places, plane of the railhead, lateral wears occur the more of the course of the recover the lateral thrust exerted on the outer rail with the central figure force of the lot of the middle railhead gets worn out, with causing the wave of the rail to decrease. The loss of the wave of the rail section should not be such that its stress exceeds the permissible values. When such the stage to reach the rail renewal is called. In addition, railhead should not wear to such an extent that there is a possible worn of the flange when hitting the fish plate. 651 type of the wear on rail. The rail may phase wear the tear of the following position: on top of the railhead, vertical wear on the side of the railhead, lateral wear on the end of the rail. The laddering of the rail ends when more prominent special locations of the track. The locations are normally following the sharp curves due to the central figure forces, steep grades due to the extra forces applied to the engine, on to approach to the rail station possible due to acceleration, deceleration, in tunnels, coastal areas due to humidity and weather effects. 652 measurements of the wear. When rails can be measured by using the following methods: by weighing of the rail, profiling the rail section with the help of the lead strip, by profiling the rail section with the help of needles, by using special instruments designed to measure the profile of the rail, recording simultaneously graph paper. 653 method of reducing wear. Based on the field experience, some of the methods adopted to reduce the vertical wear, lateral wear, the straight path, the curves indicated below. Better maintenance for the track, ensure for the good packing as well with the proper alignment. Use the correct gauge to reduce the number of the joints and welding. Use the heavier and higher ultimate tensile strength rails, which are more resistant using bearing plates. The proper designing of the case for the wood and sleepers, lubricating the gauge face for the outer rails with the case for the curvers, providing check rails with the case for the sharp curve, then interchanging inner and outer rails, changing the rail and carrying over the track renewal. Alright, rail end batter. The hammering action moving over the load rail joint or batter the rail end of the course of the time that does impact the below with the contact surface between the rail and sleeper that has gone out with the ballast between the bed ballast in place where the sleepers are. Joining and getting it, shaking up the first bolt that becomes loose. All the factors further warm the situation, thereby increase the rail and the deep end batter. Rail end batters, remember the difference between the length of the rail with the end of the point of 30 centimeters away from the end. If the batter is up to 2 millimeters, it is classified as average. If it's between 2 millimeters and 3 millimeters, it is classified as severe. And the rail battery is rail batter is excessive for the rail. Otherwise, all right. The end can be cropped and rail reused. Rail lubricants are provided with the sharp groove of the rail lateral wear is considerable function lubricated for the oil running phase of the outer rail. In order to reduce the friction, it has been noted that considerably reduce the wear by 50% with many of the mechanical devices can be attached to the wheels to provide lubrication and mechanical arrangements. The wheel moving the trains normally may cause the lubrication to flow outside of the rail either by the action of the wheels pressing on the plunger or down on the ramps, accounting for the rail being depressed with the wheel, sometimes for the movement of the track, and it's also caused the lubrication to flow based for the principle of the plunger being depressed, moving the wheels of the P&M type lubricators have been provided with the curves of such section of the GAT section or Central Railway. They are also working very satisfactory. For details, wears including limited of the wear chapter refer to chapter 25. Alright, 6.6 other defects of the rails. Railway, battering rail ends the two major defects in the rail. However, the same other defects may be also developed in rail necessity removal at extreme cost of the discussed below. Hogging the rails. Rail ends going hog due to more poor maintenance of the rail joint, yielding formation, loose, the faulty fastenings, other reasons. The hogging of the rails causes the quality of the track deteriorate. This can be remedied with the measure by the shovel packing for the details chapter 20. Scabbing the rails. The scabbing of the rails overdue with the falling of the patches, the chunk of the metal from the rail table. The scabbing of the generally seen in shape of the elliptical depression surface reveals the progressive fracture of numerous cracks around it. Wheel burns. Wheel burns are caused with the slipping of the driving the wheels of the locomotive on the rail surface. Consequently, extra heat that generated the surface of the rail gets affected, resulting in depression of the rail table. When the burns are generally noticed with the steep gradients where there are heavy incidents of breaking near water columns. Shelling and black spots. Shelling is progressive horizontal separation of the middle of the curve of the gauge and generally with the upper gauge corner of the prominently covered with a heavy bearing pressure small area contact with producing heavy internal shear stress. Corrugation of the rails. Corrugation of the de minimis depression of the surface of the rail varies in shape of the side of the occurring with irregular intervals. Extra cause of the air corrugation is not yet known. There must be many theories put forward that the factors we help the formation rail corrugation. However, they each are briefly enumerated here. Metallurgy, age of the rails, high nitrogen content of the rails, age, each of the oscillation time of the rolling and straightening of the rails, physical environmental condition of the track, steep range yielding formation, long tunnels with electrified sections. Training operation, high speed, high axle load, starting with the locomotive location of the train, however, where the balance of the brakes are applied to stop the train, atmospheric effects, high moisture content, actual air, particularly in coastal areas, presence of sand. The corrugation of the rails is an undesirable feature with the vehicle passing the over corrugated rails. The roaring sound is produced possibly due to locking of the air in corrugation. The phenomenon, sometimes called the roaring of the rails, unpleasantly excessive noise caused with the greater inconvenience of the passenger. Corrugation also results rapid oscillation of the rails, which turns loose the keys that cause excessive wear to the fitting of the distribution of the packing. Corrugation can be removed with the grinding railhead with a fraction of a millimeter. No method of the standardization Indian rails to grind the surface. The problem corrugation, however, has been tackled with greater detail on the German railways. And the two types of equipment are normally used with the rail grinding and motor-driven trolleys on one or more of the rail slow speeds, grinding the individual reels borne by one rail grinding train, which moves at about 30 kilometers per hour and grinds both rails and simultaneously. Are your rail failure? Rail is said to have failed and considerably necessary to remove them immediately with the track account with the defects noticed on it. The majority of the rail features originate with fatigue cracks that you cause due alternating created in the rail section. Account of the passage load of the rail section is normally designed a certain minimum of gross million tons of traffic, but sometimes due to reasons such as an inherent defective metal distraction becomes a weak in a particular point and leads to premature failure of the rail. 617. The cause of the rail failures. The main cause of the failure of the rails are flaws. The inherent defects of the rail, the manufactured defects of the rail, such as the faulty chemical composition, harmful segregation, piping, seams, laps, and guide marks. Defects of the rolling stock, abnormal traffic flaps, spots in tires, engine skid of the wing, surface braking, etc. Effective corrosion, excessive corrosion of the rails. If the corrosion of the rail is highly generally taken place due to the weather condition, presence of the corrosive salts, such as chloride, constant exposure of the rail, moisture, the high humidity location near the water, the columns, aspects, tunnels, etc. Corrosion normally leads to the development of the cracks in regions with higher concentration stress. Bad maintained joints and poor maintenance of the joints, such as improper packing with the joint sleepers, loose fittings, defective in the welding joints, defective arises because of the improper composition, thermal white welding metal, or becoming the defective welding technique, improper maintenance of the track, and ineffective careless maintenance of the track of the delayed renewal of the track, derailments to cause damage of the cover of the rail during the derailment. 672. The classification rail failure. The classification rail failures on the railways has been codified with the easy process statistical data. The code made up of two portions. The first portion for the consisting of three code. The second portion consisting of three or four codes. Digit the first portion of the code. The three code letter made up of the first portion of the denote the following. The type of the rails being used: O for the plain rail, X for the points crossing rail, region for the withdrawal with the F for the fracture, C for the cracker, D for the defect. Yeah. Probable cause for failure, S for the fall of the rolling stock, C for the excessive corrosion, D for the derailment, O for the others. Second portion of the code. The second portion consists of the three or four digits. Give the following information: location of the fracture of the length of the rail, one for the fish plate with the limits, two of the other portion of the rail, position of the rail section with the failure standard of 0 for unknown, one for the rail within the railhead, two for the surface of the rail, three for the web, four for the foot, direction of the crack fixture 0 to 9. Any other information for the fracture would be necessary to provide the further subdivision, and no specific system is recommended for this code. 673. The metallurgic investigation. The following type of defective rail should be normally sent to the metallurgic investigation. Rails have them removed from the track as a result of visual ultrasonic detection. Rail failures falling in categories which cracks and surface defects develop in a specified location. Alright, 6-8, rail flaw detection. Deflecting rail will ultimately lead to the fracture breaking of the rail to cover the flaw of the portion of the view of the ultimate consequence of the flaw resulting in the fracture necessary to detect the flaws, taking timely action to remove them. Rail flaws can be detected either visual examination of the rail end of the rail flaw detection equipment. The visual examination of the rail ends. The method of the joint is first opened after the removing the fish plates. The rail end has been cleaning over the corrosion with using kerosene oil to visually examine detail with the help of the magnifying glass with any hair cracks, etc. White chalk was sometimes rubbed on the rail end so that it identifies the flaw clearly. A mirror is used to reflect the light of the joint, causing sufficient light is not available. Ultrasonic rail flaw detectors. Ultrasonic rail flaw detectors have been progressively used in recent years for the Indian railway deflection of the flaw. The method is also known as the non-destructive method of testing rails. Or 681, theory of the ultrasonic rail flaw detector. The vibration wave with the frequency more than 20,000 cycles per second from the term of the ultrasonic wave. These waves that prominent at the beginning are able to pass through metals following the normal principle of the light wave, the reflection and reflection of the transmission. Whenever the change of the medium, the score of the ultrasonic energy gets reflected, rest gets transmitted. The amount of the energy reflected depends on the physical property of the two media. When traveling through the steel, these waves across the air through the bottom of the steel from any of the flaw inside of the steel. The reflection is almost 100% of the property has been found most useful for detecting flaws in the rail. Thus, when ultrasonic waves are fed for the location of the rail on a rail, they pass through the rail metal and normally reflected only from the foot. However, the discontinuity exists in the rail metal due to the sum of the flaw. The ultrasonic wave gets reflected back from the location of the flaw, which can be picked up and deflected located. Production ultrasonic wave. There are several methods of producing ultrasonic wave. The most common is a simple method of producing ultrasonic frequency using a crystal transducer. Normally produced for the ultrasonic wave of the frequency up to 15 megahertz. The crystal is generalized for the purpose of that of either the quartz or barium titanate that can be cut in a special shape of the dimensions. Because these crystals have peculiar property to change the dimension, general variation in particular direction. The oscillation electrical charge is applied by crystal bases. When these crystals are made with the vibrate, they produce an oscillating electrical current. The crystals also shall have their potential generating ultrasonic vibrations, also converting of the wave received after the reflection into the electrical current. They also possess reversible property. The crystals are have the metal holders protected with the superior quality perspex, and they are termed probe. There are two types of probes using ultrasonic testing. Normal probe. The probe consists of two semi-cylindrical crystals which are vertically separating layer of the crystal and perspex. The probe transmits ultrasonic wave vertically downwards when putting on the rail and are suitable for the detecting of the horizontal inclined flaw, including bolt hole and cracks. Angle probe. The probe crystal is mounted on an angular surface capable of transmitting the pulses in an outward angle which may forward and backward, both separating, transmitting and receiving the crystal wave emitted by these probes follow the inclined path and suitable deflected inclined and vertical defects. Your techniques of ultrasonic testing. The number of the techniques have been in ultrasonic testing to suit the design of the different equipment. Some of these techniques are as follows: the frequency modulation, pulse echo, the transmission resonance, acoustic wave. The Indian Railway used the frequency modulation, pulse echo techniques, and only those discussed in detail here. Frequency modulation technique. The items utilization frequency modulation. Ultrasonic waves created with the help of the probe crystal and transmitted continuously in rail, rapidly changing the frequency necessary from the railhead to be wet would enable the ultrasonic waves to pass efficiently from the crystal to the rail. The waves get reflected with the opposite face of the received the continuous by the crystal. There are interference between the transmitted wave and the reflected wave, which cause the reconnaissance. The frequencies of the transmitted wave change the consistency, such as the resonances take place at regular intervals with the position reflection change due to the flow of the metal. The resonance gets affected, which can be easily detected with the operator. Instrument manufacturing principle of the Audi gauge are light and portable, simple machines. However, they are certain limitations. Fine vertical cracks are not readily detected because the single vertical probe does not find any surface defects from which it can be reflected. Cracks, holy bellow, bolt holes are not also detected, but the vibrations are interrupted by a hole. Your pulse echo system. Pulse echo technique. The pulse ultrasonic beam with the high frequency produces the pulse generated with the end of the rail at the opposite side of the ultrasonic wave that is reflected, and the echo is picked up by the crystal transducer. Discontinue the defect of the rail was also produced by the echo. The time interval between the initial pulse arrival of the echo is measured with the help of the cathode by ray of the tube. There may be multiple reflections of the echo by one arising due to the fault. The can easily determine the relatively position amplitude. More sophisticated type of instruments that are based on the pulse echo system are being manufactured by the first from Crott and Kramer at present. or your Croton Kramer multiple probe rail testing trolley. The most common type of equipment for the Indian Railway, the detecting flaw of the rail with the figure of 6 to 8, with the equipment is fitted with a holly hand trolley so that it can be carried on the rails, and then the two probes normally probe with an angle probe, and then both act independently. The probe material leave the production ultrasonic wave, then barium tinnate, with which produce the transmit vertical ultrasonic sounds for forward megacycle frequency through vertical probe, 2 megacycle frequency through angle probe. The cylindrical probe is mounted on the knuckle jointed holder frame with its renewable backlight wear plate at the base. The probe is worked over the rail with a bakelite piece that takes aware of the complete. The height of the probe above the rail surface can be adjusted with the holder. Assembly the normal probe is forward and power enough to scan the entire rail. The depth of defects that can defect the longitudinal discontinuities in the head of the function either of the web or over the foot of the web, the head of the as well with the cracks from the bolt holes. It cannot, however, detect vertical crack. The defects detected with the normal probe are presented in the oscilloscope stream that is form over the firm echoes, producing the baseline for ordinarily 2 echoes are visible on the screen. The initial echo due to the partial reflection of the wave from the rail top to the back of the echo from the bottom of the rail. Any of the echo between the initial and back of the echo, corresponding reduction in height of the back echo is determined as a flaw echo, an indicator of the flaw, indicating of the flaw. The position of the flaw can be known by reading of the distance of the intermediate echo for the initial echo, which may be the distance flaw with the rail at the top. Ultrasonic rail testing trolley can be used without any block protection, but can also only has vigilant about movement of the trains. Progressive depends upon the experience of the efficiency of the operator. The work is continuous, strenuous in nature, with a single operator cannot observe the screen continuously for a long time. Work can also be not done during the middle of the day. In the summer months, because the operator will not be able to pick up the signal clearly. On account, these in limitation of the work process rather slowly, and approximately 2 to 3 kilometers of a rail are covered per day with 2 operators. This shows your ultrasonic rail testing trolley. Figure 6.8. 6A3 classification of rail flaws. Depending on the natural extent of the internal flaws and the attractiveness and the speed of the section defects and notice of the rail flaws detection method that have been classified as in 3 major categories: IMR, REM, or OBS. IMR, it affects serious nature can be believed with the sudden failure of the classified IMR or immediately after detection. The classified fish plate should be provided with a defective portion speed restriction of 30 kilometers per hour. The imposed until the IMR rail is removed. The sound testing rail plate piece of the not less than 6 millimeter, so not less than 6 meters. The watchman should be posted till the clampfish plate are provided with avoid any mishap of the IMR standing immediate removal. REM defects. The type of the defects are warranty early removal of the rail from the defect. The defects are marked with the red paint and the REM stands for remove. OBS. The defects are not serious. The rail does not need to be removed. In such a case, they kept under the observation. The defects are marked as yellow paint. The OBS stands for observed. The OBS should have the further classification OBSE, OBSB, and any OBS defect located with the fish plate zone is designated OBSE. Similarly, OBS defect of the major bridges upon 100 meters on their approach is designated OBSB. In this case, the need based on the concept of ultrasonic testing is explained in section A686. There are only 2 types of deflection, IMR and OBS. However, if the defects are occurred with a welded joint, they are called IMR Rs or OBSW. The defects, the actions to be taken, the deflection defects, of course, are summarized in Table 610. Alright, your classification defects: IMR, Red Star 3, REM, Red Star 2, Red Star 1, OBSE, OBSR, Red Star 1. Place an immediate replacement not later than 3 days. IMR Red 3 Star. Impose 30 kilometer hour depot watchman defect of the part replaced. Replaced within 15 days of the Red Star with imposed 30 kilometer hour to replace. And the rest of them are replaced within 15 days, 30 mile an hour, and if not replaced within 15 days. In case of the OBS rather than the OBSE, the OBSD permanent way of the inspector PDWI. Permanent way inspector should observe the OBSE location with magnifying glass of the duty record the observation once a month to see if the crack can be developed further. In such a case, same case, the REM defect should be taken. The permanent way inspector should maintain sleep with the fitting of the ballast to each of the such location sound condition. The system engineer should also check some of the OBS location record observation during the monthly push trolley inspection of each section. Alright, 684 ultrasonic rail flaw testing car. The portable ultrasonic rail flaw detector can test only 2 to 3 kilometers rail per every day. Advanced railways, such as the German railways, have developed a rail testing car that can test a much longer length of the track much more effectively. The test car tests the track at speeds of 30 kilometers per hour. Each of the two rails is tested or ultrasonically by the means of the 5 probes: 0 degrees, 35 plus or minus 35 degrees, plus or minus 7 degrees. Airborne sound assembly test results recorded with the photographic on tape. The subsequent examination of which can reveal all the flaws. The flaws can be properly classified. The portion, the position track can also be pinpointed with respect to the kilometer age and an accuracy of 1 meter. The special car test the track during the day with the cover the 100 to 200 kilometers per day. The car covers approximately 20,000 kilometers of the track every year with the German rail. The average cost of testing of the railroads are 300 to 500 per kilometer of the track, which the present tend to increase the speed with the need of the ultrasonic inspection of the rails has felt all more than advised would have to do with the rail fractures. In this context, the use of the test car for the Indian Railways is considered technical operational necessary. 685 self-propelled ultrasonic rail testing car. Independent railways and Indian Railways recently procedure of the self-propelled ultrasonic rail testing car or spurt called the Matrix VR 404 say Matrix Industry Paris at the total consideration approximately 25 million. Inclusive ancillary equipment. The Matrix car is capable of detecting, measuring, recording, and simultaneously analyzing internal defects rail using non-destructive method of rail flaw deflection. Rail testing has been designed for the simultaneous examination of the rail points crossing a maximum speed of 40 kilometers per hour. They consist of the following parts: ultrasonic detection lower, the electronic unit, including all circuit transmitter, receiver, the selector, the auxiliary, 2 multi-track recorders installed at either end of the car, real-time automatic defector, analyze the various components of the rail flaw detecting equipment are shown in the schematic diagram 5.6. Figure 6.9 test is done using 5 probes at different angles, which are able to deflect the rolls. Or yeah, they're half the cathodic tube, the receiver, and the transmitter receiver. They're going into the rail probe and rail probe. The spurt cart can be detect most of the rail defects normally develop. They under the traffic during the survey. The type of the defects decide with the portion of the rail section automatically determine. The spurt cart is able to screen the rail section completely in the web, almost completely in the head for the zone of the foot below the web, the flange of the foot, and the top of the corners of the head. However, the downscreen with the defective recorded are automatically analyzed. Results are given and synthesized from a prescribed manner. The example of the spurt car will be used extensively in the railways. It will be possible to control the rail fractures and failures of the Indian Railways to a considerable extent. 686 need of base concepts and UFS ultrasound USFD testing. Indian Railways have decided to introduce the system need based concept, the USFD testing based on Russian concepts as a person for the present policy. The need rail inspection progressively introduced and not covered under the spurt car. The B&D route for the Indian Railway's introduction concept with the required change for the present classification of the defects, frequency, inspection for the detection, equipment, and organization. The following the important feature of the need-based claim of the ultrasonic flyway detector testing. Traffic density and periodically. The need of the base for the concept stimulated frequency ultrasonic inspection 1 after the passage of every 800 gross million tons with a periodic varying of 2 to 6 months depending on the sectional gross million tons. Important related to parameters. The system has evolved the base for the consideration 2 important related parameters: permissible condemnable defects, size, inspection frequency. Other important factor of the microstructure of this rail steel nature, orientation of the crack that have never been taken into consideration. Defect size. Under the concept of the defect size, the 12 millimeters above the head of the 5 millimeters above the web junction and section is taken into account with the classification of the defects. Therefore, the defect size below 12 millimeters, 5 millimeters are allowed to continue with the tracks. Unclassified defects further than the same size of the artificial flaw with the 12 millimeters considered with the classifying the weld defect to the attention from the absorption of ultrasonic energy supposed to be measure the SKV ATW welding joints to the coarse grain with where some absorption of the energy is less rail steel. The SKV is the German word for the meaning of the short preheating. AT denotes the aluminothermite, obviously specified with the 60% peak height, would not be available in the same grain setting in the case of the welding. The frequency testing of the rails and welds, inspection of frequency of the 8 million gross tons that has been prescribed with the need-based concept of the ultrasonic testing. The higher inspection frequency may be fixed depending upon the incident of the defects, the viewing of the whenever they use the defect of the generation failure for the server, the defects detected during the ultrasonic frequency detection and inspection is 1 per kilometer. Excessive testing is stretch. Inspection frequency should be doubled in particular strength when calculating the defect generation rate. Only real defects IMR fractures with apparent original other than the bowl area detected by the ultrasonic frequency detector should be considered. Or testing of the rails, initial and testing of the rail of the manufacturer plant with the first retest of normal need not to be done with it until the rails covered 15% of their service life. Gross million tons are given the table 611 for the rails rolled in April 1999. Later, the test free period will be 25% instead of 15%. Our surface of the rails, gauge rail section, broad gauge and meter gauge, 60, 52, 90R. It says gross million tons for T12 to 72 UTS runs 550, 350, 250, and UTS 90 units, 80, 525, 375, meter gauge 75R and 60R, 172 UTS is 150 to 125, and 90 UTS is 225. Whenever the rails are not tested for the rail manufacturing plant, the test free with the applicable the rail testing will be done periodically interval to give them the 612 the rate from the day of the spin laying field with the table to give them the frequency ultrasonic testing after the passage of the 8 million gross tons subject to the maximum interval of 1 year. If need-based concept actions suggested in Table 613 when taken, the defective rails are defective. IMRW, OBS, OBSW, and your summary. Various types of the rail sections of their specification was discussed in the chapter of the flat footage site. Rails are commonly Euphanian rails. The rail section may be developed in different types of defects during the surface life of the defects in the rail should immediately attend. Otherwise, it will lead to the failure of the rail. The various types of defects in rail remedial measures to adopt have been highlighted in this chapter. Chapter 7, Sleepers.